Okay, everybody. So today I'm going to talk a little bit about our use of Scratch 3 in a distance pair programming format. And so if you just want to forward on, Darren, that's great. So the agenda is just a very brief bit about me and the primary technologies set of courses that we've got at the University of Glasgow. I'll keep that very brief. And then the biggest part will be just the organisation of our distance pair programming sessions using video conferencing software. So we use Zoom, but actually this could, it's quite a straightforward method, and you can use this pretty much with either Microsoft Teams or possibly even Google Meets, as I noticed that it's got a breakout room option. And then the last thing we'll do is we'll take a wee quick look at the views of our student teachers on this approach and just some of our own kind of thoughts on it, because obviously this is the first time that we've used pair programming in this kind of way. So I'm formerly a computing teacher and faculty head for 13 years, and for the last 4 years I've been at the University of Glasgow, and actually my main area of responsibility has been the primaries technology curricular area. So in that time we've completely redeveloped what we do, and we're trying to kind of give as strong and firm a foundation in the technologies area of the curriculum as we can, so that students coming out have the confidence to kind of bring this curricular area to life. And obviously the computing science part of that is really important as well. So if you just move on. So our primary technologies course is currently organised in this way. We've got 5 active lectures. We've got 100 plus students in those, and they're about 2 hours. And then we've got 5 workshops scattered throughout in between the lectures. We've got 6 this year, and they usually have about sort of 50 students in them. So they're kind of large sessions. They are kind of active and interactive. And you can see from the sessions below that the we take a kind of media computation approach. So we try and share with them creative projects, things that would be interesting for their own pupils to kind of create and do. Could you move on, please, Dan? So why did we choose pair programming? Well, we do a survey at the start of every year with the year groups about the technologies and just, what they think about different areas of the curriculum in terms of their importance, and also their level of sort of teaching self-efficacy. And we took that from an existing survey that's out there. And the great thing is that all of the students, pretty much all of them on the Masters Education PGD, agree about the importance of teaching computing science, but the majority have low levels of self-efficacy about teaching primary computing science and the key skills, resources and approaches they could use. And it usually varies, but it's about 60 to 80% disagreement when it comes to the statements about their confidence in being able to handle classroom situations that involve computing science skills. So it's really critical that their own learning experience doesn't lower this self-efficacy any further. And we think, obviously, that peer support is crucial to building student confidence. So we use pair programming for that reason. We did it face-to-face, and we really wanted to kind of replicate that when we moved to fully distance learning, as everybody had to do in our university. So if we just move on to the next slide, please, Darren, if that's okay. So how do we support distance pair programmers? Well, there's 2 kind of structural things that we do. I've got a Scratch teacher account, and I actually create a Scratch classroom, and then I have a sign-up link that the students can use to join a class. And basically it means that they automatically get added to any class galleries. So we have a gallery with starter files, we've got completed examples, and we've got a range of galleries where they can share projects that they've been working on with each other. And also the nice thing about it is I can dip in and I can actually look at the list of the activity for each class, and I can pick out projects and share them when we come together as a group. And we also have a series of links, direct links to some of the activities for the navigator or the driver. And basically these are just designed so that they can quickly click the link and have the material open when they move into the breakout room. And so usually sort of documents by exercises, other support materials can either be downloaded, or we can link them to kind of view only online versions. they can take a copy and then they can share that with the other people that they happen to be working with. So what happens during a live session? Well, we've got usually sort of whole group pieces, 10 to 20-minute chunks, wee bit of explanation, demonstration of key ideas, and we do a lot of responses via chat, reactions and polls. And then what we do for the first pair activity is we use the breakouts automatic allocation feature. So we did initially have it that it was pairs, and what we've found because of the actual some of the wireless issues, that sometimes you get a student that drops out, and obviously when they come back in and put them into the room, it can be a wee bit of a slow start. So we've kind of moved more towards trying to have threes rather than pairs. So if there are any kind of technical issues, you've still got someone who's a pair. And what we do is we reuse those rooms for the other pair tasks. So we've got breakout rooms, and usually the sort of activities that we have, it's sort of 15 to 30-minute chunks. They open any provided materials on Moodle in the starter files gallery, and then they can use their microphone, shared screens and annotation and chat to coordinate their work. So we do a little bit of kind of demonstration of the process of working as a pair, just so that they've got a clear idea about exactly how we would like them to kind of discuss and exchange ideas. So we've got two main types of pairings that we use. We've got side by side, so that's two computers and two Scratch projects, and really they can act as programming partners. So we encourage them to discuss what they need to do at the start of the activity, and then they work on completing the activity individually, but we encourage them to share their screen whenever they require, and that allows them to provide a wee bit of help and support, and also demonstrate their solution and approach. So if they have taken slightly different approaches, they can actually see that. And the second type that we use is kind of more traditional paired programming, and that's a joint project. So they do have two computers, but we have one driver who creates the Scratch project and they share their screen, and then the navigator has any other materials, so tutorials or exercise instructions, and then they guide the driver on how to interact with Scratch, suggest ideas, and the driver then gets a chance to kind of act on the guidance and discuss the suggestions. What we've found with the distance version, that normally when you're doing paired programming, you would swap every so often. And what we do is we swap after each activity. So we do try to keep the activities a little bit shorter, so that they're not quite as extended, and that just means that after each activity is complete, then they swap roles, and the navigator gets the chance to be the driver, and the driver gets the chance to kind of advise them and to give them ideas of what they're doing. We've got a range of different paired tasks that we use. These aren't the only ones that we use, but I just thought I would give a few illustrative examples. But we basically try and use the use, modify, create learning progression. So we start off with very short activities that are about looking at an existing project, trying to describe the behaviour, what they can actually see on the screen, and then also delving into the code and making predictions about what it will do. We then move on to kind of tasks that are more about modifying, so fixing buggy code or carrying out experiments with the commands. And then finally, towards the latter parts of the session, we do more create type tasks. So put the blocks provided in the right order to do a certain animation, or we have a worked example, so like a tutorial where it talks them through how to use particular programming features in order to create a program. So one of the things that we do in the early stages is the rock band, where they get to kind of create their own instruments and use the event handlers for key presses and mouse clicks. So the students' views, we asked them, what their experience was for pair programming, just do a little bit of reflection, and having gone through the comments, basically 95% of them were completely positive. There was no negatives there, and there was a few that had mentioned a couple of slight concerns. So if you just click again, Darren, just to bring up the illustrative quotes. So the positive ones is up at the top. That's an example one. So you can see that they're highlighting that they feel that they're able to solve issues much quicker, and they learn more from the activity rather than those that they were working individually. For the person that kind of raised a little bit of a concern, they said about their inner control freak, that they found it pretty difficult to share responsibility, and just, obviously with the children, how that would be. So we do, have the side-by-side programming, the programming buddies, and also the driver and navigator. And we do say to them that it might be for certain kinds of tasks that you might want to do side-by-side programming rather than just pure driver and navigator pair programming. And just in terms of our own view, if you just move that on, please, Darren. So we're really happy with how flexible in general the pair programming approach is. It'll basically work with any programming environment as long as you've got breakout rooms and people in the breakout rooms can share their screen. And also the Scratch Classroom makes it really easy for the pairs to get up to speed really quickly. And because they can share their work, it means that when we bring them back, we can actually dive into a particular project. We can show a few, we can encourage people to kind of discuss how they approach certain things or any difficulties that they had. And also the sort of general level of enjoyment. So the students really enjoy programming in pairs, and they feel that they get a lot more peer support. And certainly from some of the comments that we had, and some of the less confident students would actually have struggled to complete some of the activities if they didn't have their partner. So they really appreciated having someone to be able to bounce ideas off of. Things that we'd like to kind of explore a little bit more, we don't pair students by level of confidence. And I've found that actually when it comes to pair programming, that's the most successful method that I've found, where you tend to get reasonably well working pairs. So you pair high confidence students together and then lower confidence students together. And usually that means that they're a lot more comfortable working with one another, and you don't get the issues with one person dominating another person maybe taking a back seat. We'd also like to sort of design pair program specific instructional materials. So a lot of the existing activities that we use were originally designed for individual students. And so there is actually some research looking at how you might design materials for a navigator to encourage more particular types of discussion between the pairs. So that's something that we would like to kind of explore in a little bit more. And just, obviously the students' own digital literacy, they've gradually gotten much quicker at some of these things. But I think at the start, just screen sharing, annotation, and I think actually the biggest kind of bump a little bit is the setting up shared office documents. So some students forget that they can just quickly generate a link and then paste it in the chat window and allow their partner to actually edit the document at the same time, which does make, if you're carrying out an investigation and you're writing up the results, it does make it a little bit easier if you've got two people able to kind of contribute to it. So that's it for me. Just a couple of acknowledgements. Really, I'm lucky to work with so many enthusiastic students. The primary student teachers that we have are great, and also my colleagues. I've got two colleagues who I work with. Kenneth's here at the meeting, and also Brian Leslie. So sense of humour, suggestions, support for students has been fantastic. And there's just underneath a little bit of pointers to some of the materials that we draw upon and we use during our pair programming work. So always happy to get in touch. We're always interested to know what's going out in schools and to be able to share that with our students. So if you do want to get in touch, there's my contact details there. Thanks very much, everybody.